Hey there, so now we're going to be looking at Physics 30 Workbook page 199, question 12. And this is one of those Michelson's value of the speed of light experiments. And we're going to be calculating the speed of light using this 8-sided mirror. And that mirror is going to be rotating at 527.6 hertz. And it's placed 35.51 kilometers from a plane mirror. So just to kind of go over how this works, a light is going to be shone at one of the mirrors here, at which point it will be reflected to a plane mirror, reflected back at the same angle. And if we have the frequency just right, so that from the time it takes to go here to here, that this rotating mirror rotates this mirror here to this one, it will be observed by the detector over on this side. So to get started, we are going to use our grasp method of problem solving, starting by writing down what we are given. So we are given the frequency, which is 527.6 hertz. We are given the distance from the mirror to the plane mirror of 35,510 meters. Notice that I've converted from kilometers to the base unit meters. And I also know that the time it takes for the light to go from this mirror over to this mirror is going to be 1/8 of a turn. So then let's write down what we're required. Well, we're going to be asked to determine the speed of light. And if we are looking for the speed of light, that means we must need to start with V equals d over t. So let's write that down. So that means we need to know the distance the light travels divided by the time it takes to travel that distance. Well, we were given the distance between the rotating mirror and the plane mirror, but the light actually travels there and back. So we know that the distance is going to equal 2 times 35,510 meters, which when we put into the calculator, that's going to give us 71,020 meters. Just like that. The next thing we're going to want to do is determine the time. Well, we know that the time is going to equal 1/8 of a turn. In other words, it's going to equal the time it takes for one complete turn, or the period. But we also know that the period is related to the frequency by the formula 1/f, and you can just look on your formula sheet for that. So we could just replace this t into here. In other words, our time is going to be equal to 1/8 times the frequency. So let's plug in our values right there. We go 1/8 times 527.6 hertz. Remember, hertz is 1/seconds. And if we put that into the calculator, we determine that the time, really itty-bitty time, of 2.369219 times 10 to the minus 4 seconds. So that's going to be the time now. We know the distance, and we can put it all together. T equals distance over time to equal 71,020 meters, all over 2.369219 times 10 to the minus 4 meters, 4 seconds. And we know we got it right. We got meters over seconds, or meters per second, for our speed. And if we put that into the calculator, we get this really big old number. So 299,761,216 meters per second. Now remember, we have 4 significant digits here. 4 significant digits here. So when I paraphrase that, I want to make sure I quote the right number of significant digits. So I can state that the speed of light is 2.998, so the 7 gets rounded to the 8, times 10 to the 8 meters per second.